Let's take a look at the solution for the check your understanding. It says determine two ways to restrict the domain so that its inverse is a function. Write the equation of the inverse each time. Use a graph to illustrate each way. So first of all, they mathematically switch the x and the y so that they have this function. Now the two ways are if x is greater than 1 in the original function, then y, the range for my inverse will be y is greater than 1. Just to sort of show you here, so if you're in the original one, if I add this and say x is greater than equal to 1, then what's going to happen is that you can anticipate that y is going to be greater than equal to 1 in my inverse function, pardon me. So the greater one will be one that has a plus here, so it'll be the plus version. So if I say x is greater than or equal to 1, then that will turn into the plus version here. If I was to change this and say x is less than or equal to 1, then it would be the negative version here. So I would say negative, not plus or minus, but only negative. Okay. Why don't I go over to Desmos.com and do the sketching for it. So I plugged in x minus 1 all squared plus 3. So if I say x is greater than 1, then here I'll just draw, there is my inverse function reflected across that y is equal to x. So that 1 comma 3 becomes 3 comma 1, and 0 comma 4 becomes 4 comma 0. But if I add this restriction to say this is going to be greater than, then you're going to get the greater than version. So here I'll say in parentheses x is greater than or equal to 1. And so you see it restricts my original function, and here is, this would be the greater one. So let me just test it out here. Y is square root of x minus 3 plus 1. So if I type 1 in here, if I get rid of this one and say y is equal to the square root of x, what was it again? Minus 3 plus 1. So that's the same one, isn't it? So if I add this, see that this is the exact same as writing it that way. The plus here, because this is greater than 1. When you think about the fact that here, that you realize that y has to be greater than or equal to 1. The largest that, like this value here, the smallest that it could be is 0, right? You can't get a negative value out of here. So the y is going to be equal to some number. The range between this is 0 up to infinity. So it's going to start, it has to be at least 1, and it's going to get larger than that, right? So that's why this has to be greater than or equal to 1. Now if I said y is equal to the negative, the square root of x minus 3 plus 1. This square root of x minus 3 part, this part here, will always return a positive value, and then with a minus out front, it's going to be always negative. So negative times the square root of x minus 3 is always going to be negative, and so y has to be less than or equal to 1. So that's why whatever, if this is x is greater than or equal to 1, then you're going to get the plus version out front. If y is less than or equal to 1, you'll get the minus version out front. So if I just get rid of this again, you'll notice how that associates here. This part turns into that part, so we no longer fail the vertical line test, so this is a function. If I was to change this the other way, less than or equal to 1, you get this piece corresponds with that. Okay, so let's go on to our last part here, example number 4. Hide our solutions for now. It says, determine algebraically whether the functions in each pair are inverses of each other. So in y is equal to 7x minus 3, we switch the x and the y, solve for y, and they do get the same value. So the first one would be check, yeah, did it. They are inverses of each other. Looking at the second one, they do the first step again, y is equal to x minus 2 all squared plus 1. Over here they switch the x and the y, and now they're solving for y. And remember, y minus 2 all squared, at this point when they square root both sides, you need to do the plus or the minus. So this x minus 2 all squared plus 1, you know what, I'll go plug it in here. X minus 2 all squared, what was it? Plus 1. And I won't put any restriction in here. Okay, so here's my original function, and there is the inverse of it. It kind of overlaps, doesn't it? You'll notice that wherever the original function crosses y equals x, that's where the inverse will also touch, and 2 comma 1 is the vertex, so here you get 1 comma 2, so it looks kind of crazy. But if you just look at the inverse function, this one is not a function because it would not pass the vertical line test. So if I was to say, oh, here's the vertex, right? So if I could say anything where y is greater than 2, if I just took the y is greater than 2 part, then that would be great. So if I did that restriction over here, I could say x is greater than or equal to 2. Because the restriction on the domain for my original function will create the restriction on the range for my other function. So if I show that, there is my original one and there is my inverse. So going back and looking at the question, here they made x the smaller version, so this would have to have a minus to make it work. So these are not going to be inverses of each other. They would be an inverse if we put a minus here instead, or if we change this to the greater than or equal to 2. So I'd like you to try the check your understanding for question number 4. I'm just going to pause for about 5 seconds. I really encourage you to stop the video at this point and do the work for the check your understanding, and then check your solutions with me. So I'll just wait for about 5 seconds while you pause and do the work. Alright, so here are the solutions. So the y 3x minus 6, same idea. You switch the x and the y. Turns out it's not the same, is it? Because now here we get y is equal to x plus 6 over 3, and there you were asked to see if it was the same as y is equal to x minus 6 over 3. So no, these are not the same. And now looking at number 2, assuming that negative x squared plus 3, when you switch x and y, is going to turn into the square root of 3 minus x. Let's look at this. X is greater than or equal to 0, so that means I want the version with the plus here, so that part looks good. So they didn't make the mistake, they didn't catch you like they did over in the example, where this was less than, so that had to be the minus version. Here, if this is greater than, then that would have to be the plus version. So let's see. If they switch the x and the y, do the square root, so we do get plus or minus 3 minus x, and since this restriction was greater than 0, it should be the plus version. So this looks good. So part 2 does work. Alright, so here I can quickly graph that minus x squared plus 3 for you if you like, just to see how it works. Come on. So it's minus x squared plus 3. Oh, oops. There we go. There is the function. It opens downwards because it's a minus x. This is 0, 3, so on the inverse you're going to have 3, 0. Any part that is along, oh, come on. I'm kind of freezing up here. Any part that touches the y equals x, my goodness, that will be a common point. And here's what your reciprocal looks like. And if we restrict this domain for greater than or equal to 0, greater than equal to 0, and then we get the reciprocal is the purple one, or the inverse is the purple one. So as expected, y is greater than or equal to 0. And if I look at this, I don't see a negative in front of there, so y has to be greater than or equal to 0, because this square root will always give me back a 0 or a positive value. So that works out just fine. So I will see you in class. Um,